Okay, so this video is going to cover the second application that we're going to do for Pythagorean theorem, and that is applying this to algebra. So first of all, just a little kind of starter point here. We've got a little warm-up. So it says, what is the shortest distance from Kaylee to Isabella? Kaylee is the K, Isabella is the I. And we're going to describe how we might do that. So go ahead and pause the video. Think about how you might describe that distance. Okay, so one way to describe that distance would be to use just how many city blocks they'd have to go. Probably shouldn't use black there. So they could go, Kaylee could go 5 blocks this way and then 5 blocks that way. And so maybe you'd say they're 10 blocks apart. But a shorter way would be to connect them directly. And so in order to figure out how far that is, it's definitely less than 5 blocks. So we can't just count them, but it does make a nice right triangle. So we can use Pythagorean theorem to help us out on this one. So if we're going to do that, we're going to be able to say, okay, we've got, oops, sorry about that. We've got 5 squared plus 5 squared equals x squared. Well, that gives me 25, and 25 equals x squared. Put them together, we've got 50, and we'll take the square root. Now for this application, for now, we're going to go ahead and use just a decimal answer. So we'll punch that 50, square root of 50 into our calculator, and we get x equals 7.07 or 7.1 if you want to round to the nearest tenth. And those are city blocks in this case as a unit. And so that kind of is going to give us the idea here. City blocks look a whole lot like the coordinate system that you used in algebra last year when you were graphing points and lines and things like that. In addition, this picture here should look a whole lot like the slope that you did last year. Last year, you talked about slope as the rise of a line divided by its run. Well, we're not interested in the slope right now, but we are interested in its length. And so we're still going to be taking a look at these 2 legs of this right triangle, now just using the Pythagorean theorem instead of finding slope. So that's the big difference there. Now, before we move on, if you have not already, make sure you at least download and open up the handout that is posted on the Canvas page, because that's going to go along with these things here. So now, instead of having city blocks, we're just on a coordinate grid. And you see it kind of looks exactly the same here. And so all we're going to need to do is use the Pythagorean theorem. So we can look at how long the legs are. In this case, we go down 4. You could put -4 there if you wanted to. Nothing wrong with that. It's still going to come out. But if you just used 4 as well, that would be fine too. And that goes over 2. So then we can jump down and we can use our Pythagorean theorem. If you wanted to use the -4, just be careful that you've put it in parentheses, because otherwise it won't work when you type it in your calculator. Your calculator is going to need those parentheses to know that you mean take -4 times -4. So be careful with that. But you'll get the same answer if you just used 4, because this thing is still just a triangle, and we haven't had negative sides before. Just wanted to make sure that if you thought about that from last year where slope meant you went down, that it's still going to work. So -4 times -4 is 16. 2 times 2 is 4. X squared. Add those together. We get 20 equals x squared. And we'll take the square root to find out what that distance is. And again, this time, for now, I just want you to go ahead and use your calculator. So the square root of 20, my calculator says, is 4.5. 4.5. And in this case, since we don't actually know what these units are, you could put 4.5 units. Or in this case, it's fine just to leave that off. It's a distance of 4.5. So go ahead and try the next 3 here on your own, B, C, and D. And then we'll come back after you've tried that and just go over them real quickly. Okay, so hopefully you did try it. Again, you actually have to try this stuff. You can't just watch me do it, because you have to do it, not me. So I'm going to look at this one. I've got my triangle here. This one goes over 1, 2, 3, 4, 5, 6 units, and up to And so again, I'm just going to use my Pythagorean theorem. 6 squared plus 2 squared equals x squared. Sorry about the writing. I'm writing on my computer screen. So 36 plus 4 equals x squared. Well, 36 and 4 makes 40. And we'll take the square root. And Mr. Calculator says square root of 40 is 6.3. So we've got 6.3 units is x. There you go. Continuing on here, they don't get a whole lot harder at this point. As long as you can count the distances, you don't really have to do a whole lot. So here we've got 2 units. You could write that as -2 if you wanted to, no big deal. Be careful counting. So here we've got 1, 2, 3, 4, 5, 6, 7, 8. Remember, you're counting the boxes, right? The number of spaces that you've moved. Not, don't count 1, 2, 3, 4, because then you'll get extras. Count the actual number of hops that you have to take. So here, 2 squared is 4, 8 squared is 64. Add them together, you get 68, and take the square root. You should have ended up with 8.2 units. I'm not going to show all the work there. And this one, we've got 1, 2, 3, 4, 5, 6 down, and 1, 2, 3, 4, 5, 6, 7, 8 over, and you should have ended up with exactly 10 units there. No need to round. So as long as they're drawn on the graph and you can count them, that's all there is to it. There's really not much more that you would need to be able to do with this stuff. But let's imagine a situation where either, first of all, we might not have them on a graph. In a real life situation where you want to know the distance between 2 places, you might just have the coordinates listed, and you might need to find a way to find the distances. Well, one option would be to just graph them. So if I had the point -1, -2, I could grab my marker here and just plot that point right there. That's -1, -2. And then I've got 11, -7, which is way down here. 11, -7. The big thing here is it's going to make a big difference if you get them in the right spot. If you've got those a little bit off, if you count wrong now, it's going to cause some problems. So be careful. This might be a place where we want to start using a little bit of math as opposed to counting. And that's going to be kind of the goal we want to get to eventually anyway. So if this is -1, if I'm going in the x direction, if this is -1 and I had to go all the way up to 11, rather than counting it, how far is it from -1 to 11? Well, that's just subtracting. 11 minus -1, well, that's 12 units. Same thing here. I was at -2 and I went down to -7. Well, -7 minus -2 is -5. So I went down 5 units. Again, in this case, because we're going to end up using the Pythagorean theorem, it doesn't really matter if you use a negative number or a positive number, but I'm going to keep it negative just for now. So we've got 12 squared plus, and I got to use parentheses, especially in my calculator, -5 squared equals x squared. Well, that's 144 plus 25, because -5 times -5 is a positive number, equals x squared. If I add those together, I'm going to get 169 equals x squared. And the square root of 169 nicely comes out to 13. So I have 13 as my final answer there. So if you have the coordinates and you have a graph to put them on, or you can make a graph, like draw one yourself, you could still rely on counting, but you could also start to use a little bit of subtraction here. How far is it from -1 to 11? How far is it from -2 to -7? Because if you can do that, then you don't have to worry about making mistakes when you're counting larger numbers. And that kind of leads us to this last question on here. What if it is so far apart that you just can't realistically plot and count them? Whether, you could do it if you had enough time and if you really were determined, sure, but you'd be likely to make mistakes and it's just a lot of work. So the question then is, how can we find that distance? And I want you to think back to when you did rise over run. You didn't count the rise and the run for very long. What you did was you subtracted. And so in order to figure out how far it was from 15 to 42, 15 here over to 42 there, all you have to do is subtract. To find out how far it is from 34 to 70, all you have to do is subtract. And so if I'm looking at this, if I have these 2 points, one thing I might do is just say, okay, well, from 15 to 42, how far is that? Well, that's 42 minus 15. And my calculator says that's 27. That was a whole lot easier than graphing and counting, right? So that's my x distance, my horizontal distance, my run, whatever you want to call it. When I look at my y distance from 34 to 70, well, I'm just subtracting. And so 70 minus 34, my calculator says 70 minus 34 is 36. And so that's my rise. And now I've got the sides of my sides of my triangle, and I can go in and I can use the Pythagorean theorem again. These numbers are a little bit bigger, of course. So 36 squared is 1,296. 27 squared is 729. Add them together. We get 2,025. And we'll take the square root of those to find our answer. And this one was nice enough to come out as a whole number for us. We get 45. Now, the last step here is, can we come up with a formula? There is a formula for the Pythagorean theorem. What we just did here is going to work every single time. We're using the subtraction to find the difference in the x's. We're using subtraction to find the difference in the y's. And then we're just plugging them into the Pythagorean theorem. The really nice thing about Pythagorean theorem is because we're squaring it, it actually doesn't matter what order you subtract them in. When you did slope, you always had to subtract them in the same order. It was x2 minus x1 and y2 minus y1. It doesn't make a whole lot of difference here, but you're going to see the formula just takes that and uses it because you're used to that. So the idea here is if we have 2 points, x1 and y1, and x2 and y2, how we found those differences, how we found those rises and runs in our triangle, right? To find this rise, all we did was we took our x2 coordinate minus our x1 coordinate. And to find our rise, we just took our y2 coordinate minus our y1 coordinate. Those were our legs, so we fit those right in here into our equation. Oops, that's a y, sorry. So this is our one leg, this is our other leg, and this is the length of our segment. And then when we take the square root of that, we get the distance formula. If you want it, the distance formula that you're going to see is that the distance equals the square root, because all you have to do to solve for that length is square root everything. The square root of x2 minus x1 squared plus y2 minus y1 squared. And that's our distance formula. Now, I'm at the point here where I would say this thing it's nice. It's a good formula if you're a computer. If you're not a computer, though, that's a lot of stuff to memorize when all you really need to know is to find the length of the leg, find the length of the other leg, and use Pythagorean theorem. So this is the way I would do it, because writing all that formula out is probably more work anyway. So your work today is just going to be page 517, 1 through 7. You've got a couple of questions there where you're just finding the distance between the points. You can use the formula if you'd like. You can also just think of it as Pythagorean theorem. And then you've got a couple of other questions here to apply it. So here you've got a triangle with 3 vertices, and they want you to find the perimeter. Well, if you can find the lengths of the sides, you can find the perimeter, right? So next thing we're going to do here is just take some review time. So next week we'll be reviewing and taking our quiz over this unit. And then we have our test over the last 2 things we've done, the similar triangles and the Pythagorean theorem.